Good afternoon students. In the last class we discussed about self-induction. So what is self-induction? The phenomena of inducing EMF due to change of flux in the same coil, that is called what? Self-induction. Means by changing magnetic flux or inducing EMF in a coil due to change of flux in the same coil, we can say that what? Self-induction. What about mutual induction? If it happens, for example, we already studied about coil and coil method. So in this experiment what we done, the same experiment can again repeat here for to understand the concept of mutual induction. So these are the two coils. Here one is connected to a battery and the current starts to flow in that coil. Yes. So now the current is varying, current is increasing or decreasing. At that time only we can expect the induction, because inductor is the phenomenon what which opposes the change of current. Means when there is change of current only we can get change of flux. When there is no change of flux, there is no EMF. So when the current is increasing or decreasing, it also induces current in the other coil. Here there is no external source. Because of change of current in this coil, the EMF has induced in this coil. So assume that this is called primary coil, this is secondary coil. So we can define the statement of mutual induction as the very simple that the phenomena of, what is the phenomena here? We are inducing EMF in which coil? The phenomena of inducing EMF in secondary coil due to change of flux in primary coil. So, due to change of current in primary coil, dear students. So what we have done here? We induce EMF in secondary coil due to change of flux or current in primary coil, or we can say that the phenomena of inducing current in one coil due to change of flux in secondary coil, right? We can define anywhere, right? So here we can define the statement as N into phi s. So the magnetic flux link with the secondary coil is directly proportional to what? Current flowing in the primary coil. Because already we know that to induce EMF it should link it with flux, right? Okay, from this N phi s is equals to M into IP, or from this what is M? M is equals to what ma? N phi s by IP. So what is M? We can define coefficient of, in the similar way we define the self-induction, we are going to define mutual inductance. We can say that coefficient of mutual induction, or if you want to simply define this as what we can define? Mutual inductance. So here what is M? M is what ma? Proportionality constant called mutual inductance. Proportionality constant called what ma? Mutual inductance. Understood? So what we can define here? M as the magnetic flux linked with the secondary coil when the rate of flow of current in primary coil is, or when unit current flows in through primary coil, right? So what is mutual inductance? It is defined as the, what is this? Flux linkage. S represents what? Secondary coil. The flux linked with the secondary coil when unit current flows through primary coil. So you can define the statement as what? It is defined as what we define? N phi s is what? Magnetic flux with secondary coil. It is defined as magnetic flux linked with secondary coil, magnetic flux linked with secondary coil when unit current flows through primary coil. When unit current flows through primary coil. So what we can define mutual inductance? It is also defined as what? Magnetic flux linked with the secondary coil when unit current flows through primary coil, that is N phi s is equals to M by IP. IP is equals to 1 ampere. So M is equals to N phi s. So this is also measured in same units called what? Henry, right? One more definition we can define, right? What is that? Using the same concept. What is the concept? According to Faraday's law of electromagnetic induction. According to Faraday's law of electromagnetic induction, what is that, ma? EMF induced in secondary coil is equals to rate of change of flux in secondary coil only, right? Now, for N turns, for a coil of N turns in secondary coil, the same statement can be written as what, ma? ES is equals to minus d by dt of N phi s. Just now we have written what is N phi s. We know that N phi s is equals to M into IP. So ES is equals to what? Minus d by dt of M into IP. M is mutual induction, IP represents that the current flowing through primary coil. Because M does not changes, it won't change. So ES is equals to what? Minus M into dip by dt. So this is equals to what? Mutual induction is also defined as what? EMF induced in secondary coil when the rate of change of current is unity in primary coil. That's it. So it is defined as again EMF induced. It is defined as what, ma? EMF induced in where? ES means what? Secondary coil when rate of change of current in primary coil is unity. Means dip by dt is equals to 1 ampere per second, then the induced EMF is equals to what? Mutual inductance. So this is about what? Mutual inductance. So what is the difference between self-inductance and mutual inductance? If the EMF is in the same coil due to change of flux or change of current, is called what? Self-induction. If the EMF induced in the coil due to change of current in another coil is called what? Mutual induction. That is the difference between self-induction and mutual induction. Now, so next concept is what? Mutual induction of two coaxial solenoids. If it is one solenoid, we can discuss about self-induction of a solenoid, right? Now, we are going to discuss about what? Mutual induction of two coaxial solenoids. So, here instead of taking two coaxial solenoids, we would one solenoid on the other. That is called what? Coaxial. That is called what? Coaxial. Let us take an insulated cylinder. On this, one wire is wounded. So let us the current flowing in this one is what? Primary coil, that is considered as what? IP. Okay. Now, one more coil is wounded. On this one, to reduce the flux leakage, because how much EMF is induced in the primary coil? We should induce the same EMF in secondary coil. In this, the current should not flow, right? Because we are varying current in the primary coil, not in secondary coil. Let us consider the length of these two coils is same. What is that? L. So we can write as, let N1 be the number of turns let us assume that this is S1 and this is S2, solenoid 1 and solenoid 2. Let N1 be the number of turns in S1. So what we can write here? N1 is equals to N1 by L. The number of turns in S1 is N1. Number of turns in S2 is N2. Okay. Now, as usual, we consider there are N2 turns per unit length, right? Which one? S2. So we can write the same thing here. Let N2 be the number of turns per unit length in S2. So we can write as N2 is equals to N2 by L. Now the current is flowing in S1. So magnetic field B1 due to solenoid S1. What is B1? B1 is equals to mu naught N1 into IP. The number of turns in primary coil is N1 and the current flowing is what ma? IP. Now, because of varying current in solenoid, the magnetic flux is linked in secondary coil. So, magnetic flux linked with S2. What is the magnetic flux linked with S2? Phi 2 is equals to B1A, not B2A. Why we should write B1? The magnetic flux is linked with solenoid S2 because of the magnetic field produced in solenoid S1. That is the point we should remember. Very important point. We should not write B2 here. The magnetic flux linked with the solenoid S2 because of what? B1. What is B1 here? Mu naught N1 IP into A. Here, how many turns are there in S2? N2 turns, right? For N2 turns, the same thing we can ask what? N2 phi 2 is equals to, we should multiply this one into N2 into N2, right? So already is there. What is N2 here? N2 into L. So we can write as mu naught N1 N2 IPAL. So this is equation number 2. So means what? The magnetic flux linked with secondary coil. So we know that there is a magnetic relation between magnetic flux linked and mutual induction. What is that? N2 phi 2 is equals to M into IP. So what is N2 phi 2 here? Mu naught N1 N2 IP AL. That equals to what ma? M into IP. IP cancel. Therefore, M equals to mu naught N1 N2 AL. So here the mutual induction of two coaxial solenoids depends upon nature of medium, number of turns in primary coil, number of turns in secondary coil, area of cross section and length. So for a medium, the formula can be written as what? M is equals to mu N1 N2 AL. As we know that mu R is equals to mu by mu naught, means The relation between relative permeability and what is this? Permeability of medium, this is permeability of free space, this is relative permeability. From this we can write as, the formula can be written as what? M is equals to mu naught mu r n1 n2 al. So this is the formula for what? Mutual induction of two coaxial solenoids. Okay. So what is mutual induction? The phenomena of inducing EMF in a coil due to change of flux in another coil. Okay, right. So now next concept is what? Energy stored in an inductor. So how the energy will be stored in an inductor? Like capacitor, this function is what? To oppose the flow of current. So here in this case, how the energy stored in an inductor? Let's see. Let us consider. You know the circuit symbol of an inductor is this one. It is connected to a battery of EMF E and inductance L. Okay. Now what we can say that here an inductor is placed. So assume that this is potential V. Now when the current is switched on, what happened? The current starts to increase. When the current starts to increase, there is change in current, changes magnetic flux, it induces EMF, right? So like self-induction, what is self-induction here? E is equals to minus L into di by dt. Is it right? E is equals to what, ma? Minus L into di by. So when applied potential is V, because of this one current changes, that changing current causes induced EMF. This induced EMF opposes the flow of current. So what we can write here? Applying Kirchhoff voltage loop for closed loop. For this closed loop, what is this? The total potential difference in the closed loop is 0. What is the applied potential? V. What is the potential that has been developed? E is equals to what, ma? 0. Then V is equals to minus E. What is E here? Minus L into di by dt. So it becomes minus of minus plus L into di by dt. So to flow current in this circuit, because it is opposing that EMF what has been induced, opposing the change of flux, so we should do some work done to produce current. So let dW be the work done. dW the work done in developing current in the inductor. How much work is done? dW. In developing current, how much? I. So what is the work done? Rate of work done. dW by dt is equals to what? V into I. Power P is equals to what, ma? V into I. What is V here? L di by dt into I. dt cancel. What do you get? dW is equals to Li di. So now total work done in developing current from where to where? Initially 0, right? 0 to I, because until then only it induces EMF. So we are taking from 0 to I. What you can write here? Integration of dW is equals to integration of Li di 0 to I. Integrate. Integration of dW. W. L is constant. 0 to I into I di. What is the formula we can use? Integration of x power n into x is equals to what, ma? X power n plus 1 by n plus 1. So I can write as L into I power 1 plus 1 by 1 plus 1. 0 to I. That implies W is equals to, apply the limits, I square by 2 minus 0. So of L I square. Now this work done is stored in the form of what? Potential energy. So this work done is stored in the form of which energy? Potential energy. Whatever the work is done against the system will store in the form of potential energy, that is equals to what? Half L I square. So it is very similar to what? Potential is stored in a conductor capacitor, right? What is that? Half CV square. So here if you connect an inductor to a battery of potential V, when the switch is on, the current starts to increase. When the current changes, it induces magnetic flux or change of magnetic flux, which in turn induces EMF, that is E is equals to minus L into di by dt. We use Kirchhoff's law. So applying Kirchhoff's voltage for closed loop, V plus E is equals to 0, that implies V is equals to minus E. Now because it is opposing, we should do work done to flow current in the inductor. That work done, rate of work done is what? dw by dt is equals to V into I. What is V? L into di by dt into I. dt cancel, dw is equals to what? Li di. Total work done in developing current I 0 to I is integrating on both sides. On integration we got W is equals to half Li square. This work done is stored in the form of what? Potential energy. So these concepts are very important for 3 marks. In this chapter we are going to get 2 3-mark questions. So concentrate on these questions, you can easily score marks in final exams also. Thank you dear students.